So recently, I've been wondering how to actually explain concepts of programming to, let's say, junior developers or new developers who are starting out on their programming journey. And the common way that we teach the organization of code is via object-oriented programming, and I think it's pretty flawed. It's a pretty flawed way to look at code, to look at what software actually does, and I think a much better way, in my opinion, is essentially considering all programs, all software as being data and logic that manipulates data, or logic that interacts with data more accurately. And that actually corresponds more closely to what the processor actually does under the hood if you look at something like assembly code. So you have like program instructions, they are data, and then that data is being read by the processor and then turns them into instructions. And then those instructions are then reading and writing data in memory, or sending or receiving data from inputs or outputs. And structuring code and looking at code as data and logic, it abstracts the actual CPU operations much less than what object-oriented programming does, which is a good thing. Like abstraction is generally not really something you want to do unless it helps you understand things better. Like if abstraction makes you understand the software that you are building less, then it's not really a good thing. But if abstraction allows you to do less work but still understand what you are doing, that's generally better abstraction. And so to kind of illustrate this way of thinking as code as data and logic, I made this kind of simple example Python program. This program actually it reads input from the command line as numbers, and then you can use those inputs to construct these rectangle data, and then it checks whether one of these two rectangles that have been input, if one rectangle contains another. And here, if we go to the top and we look at the actual rectangle data structure, we are using the same tools that we would use in object-oriented programming, meaning we're using a Python class here, but we are specifically using a data class, and essentially that's what. And that's kind of what the data class decorator is designed for. It's designed to make classes that behave more like structs in a language like C, where, for example. However, the memory layout of this data is completely different, most likely because it's Python. But from the perspective of the developer looking at the data structure, it has the same set of data. It has 4 integers here, for example. And that's the data part of this class, and the second is the logic part, which is the method here. The contains method. Now methods essentially are functions. Functions are the logic part. Functions are the main function, or I suppose in Python the script, and then all the functions that it calls. Those are the logic part of your program. And what methods are basically functions that are associated with specific data types. For example, contains is a function that is associated with the rectangle data structure. So we could actually just write this contains method in another way as a function, basically. So we could, for example, we can convert this into a function in the module itself, and maybe call it rectangle contains, and then we convert self to let's say rectangle, and call it rectangle. or we can just call it self in order to avoid renaming the parameter. But essentially the method and this is the same in terms of logic. It's just the difference is how you can invoke it. So with this information that we only have data and logic in our program, we can consider programs to essentially just be big functions that take data from various inputs, process that data into another format, and then send it to various outputs. And here the inputs and outputs are kind of simple in this program. For example, when we are reading the rectangle input here, we are producing output first by writing into the standard output. And then we are reading inputs over here. So we are getting data into the program. We are producing data out of the program and getting data into the program. And then we just take this data, which is 4 integers, and put it into another format within our program. And then we essentially interact with the data, meaning we process the data. We check if one of the rectangles contains the other. And then again, after that, we produce more output from the program. And so this is a simple example, but pretty much all software is this. It's just that the inputs are a more complex collection of inputs, and the outputs are also usually more complex, and the internal data structures are more complex, and the logic. But they all consist of the same components: input, output, data, and logic. And personally, I kind of wish that schools would teach programming more like this, and all the kind of tutorial materials that you see online, that everything would teach programming more like this in terms of data and logic, because just adding object-oriented concepts on top of this, like objects or inheritance, they just kind of muddy the waters. They make programming seem more complex than it actually is. Now, don't get me wrong, there are complex problems that you sometimes need to solve with complex logic, but object-oriented programming tends to create this kind of excess complexity that's not really necessary to solve the problem. Like instead of inheritance, you can just have a composition of different data structures. And instead of inheritance, you can have a composition of different functions calling each other. So we can compose larger pieces of logic from smaller pieces of logic, and we can compose larger pieces of data from smaller pieces of data. But yeah, if for example you are a new developer, then maybe try to consider programs this way instead of trying to think about objects or inheritance or whatever, because those are just making this concept much more complex than you really need to, than it's really needed. Right, so that's an unscripted rambling of mine. I kind of got tired of editing, so my future videos are probably going to be more rare, but when I upload new videos, they're probably just going to be less scripted ramblings like this, because in the end I'm a software developer. I'm not a video editor. I don't want to spend my time editing videos or whatever. But hopefully this opened someone's eyes or helped someone think programming in a better way. All right, that's it. See you next time.